I can make the magical machines of sharing work, and I can. This is the first time we've really done this sort of webinar. This is the Cyber in Real Time webinar. It's really a story of how Seemplicity and Reco are supercharging their security analytics. For those of you who aren't super familiar with ClickHouse, I thought I'd start with just a minute or two of a ClickHouse overview. So first of all, my name's Tyler Hannon. I'm based here in Amsterdam. I look after community for ClickHouse, which basically means that I have the opportunity to tell the story about the software that other people build. So what is ClickHouse? ClickHouse is an open source columnar OLAP database. Those are all attributes, and the benefit of those attributes are that ClickHouse speaks SQL, processes data very, very quickly. It's highly efficient. It's easily scalable. But a database in isolation is meaningless. I could talk about predicate pushdown, or I could talk about query analyzer, or how we think about the notion of consensus, or what we've done in ClickHouse Cloud. It's sort of in perpetuity. I love that stuff. It's great to talk about. But the meaning in a database is the applications and use cases that people build on it. And that's really what we're gathered here today to focus on, is cyber in real time, how Seemplicity and Reco have supercharged their security analytics. But before I hand it off to our first speaker, just a reminder that the Q&A widget is there for you. If you have any questions throughout, please feel free to drop them in there, as well as chat. We're keeping an eye on both of them. We're going to leave some time for Q&A at the end. But let's start with Ravid. Ravid, would you like to share with us a bit of the story of Seemplicity?
Yeah, sure, Tyler. Thank you very much, and really happy to be here today. Let me quickly share my screen and take you through our story and what makes us work with ClickHouse. So Seemplicity is the actionable exposure management platform. I'm going to talk a bit about what our platform is doing and what the problem we are trying to solve. But really, the way I look at this is to talk about how the things that we need and the actionability and the fact that we need some results very, very fast actually meet the fastest analytical database. I'm Ravid. I'm the co-founder and chief product officer of Seemplicity, and really happy to take the discussion with you guys. So a couple of words about Seemplicity. Seemplicity come to solve the exposure management problem as it is today. For many cybersecurity teams, there is a lot of different tools that identify exposure, gaps, vulnerabilities, misconfiguration, application security issues throughout many different tools. Tools across code, across cloud, infrastructure, pen testing, on-prem assets. Each of those tools are different, having different score, different format, different type of findings. I always, talk about the fact with customers that the only thing that is probably common to all of those tools is the fact that the security team cannot fix any of those problems. Problems can be fixed by developers, IT, engineering, DevOps, operations, what have you, and they are working in Jira, in ServiceNow, in Slack, in Teams, in GitHub issues, and the security team sits in the middle and all day long trying to get findings from the tools on the left side to the people that can actually fix them on the right side. And in many organizations, this is done in a complete chaos, either spreadsheets or alerts or different methodology from different tools in a way that doesn't allow the organization to scale and become more secure, but also very, very limiting the amount of value that you can actually get from all those tools. So we have Seemplicity decided to solve this problem here in the middle and actually streamline those processes, collect the information from all those tools, but actually create automated workflows that will get those findings in the right way, with the right data, in the right time, to the people that can actually fix that. Whether it's for vulnerability management or for application security or for cloud remediation, cyber asset management, attack surface management, and so on. Taking a lot of data from many tools on one side and taking that same data and make that available to many other tools on the other side. So that's what Seemplicity is doing on a very high level. And when we started to work with our customer, there are a few things that we have realized. The first one that we realized is that scale was number one requirement. We today process more than 2 billion findings daily. Our largest customer has more than 200 million findings. We have over 160 data sources that provide us the data in different formats, in different ways, in different cadence. And our largest customers is running more than 220 automations simultaneously. And we want to take all that data, deduplicate it, aggregate it, enable some AI, and at the end of the day, make that available in different various formats, such as reports, such as tickets, such as workflows, such as actions taken in the organization. So it was clear that scale was the number one requirement. But then we actually realized that we have another number one requirement, and that number one requirement is customization. We have realized that each and every one of our customers is a bit different. Each of them want to build their organizational structure in a different way. So we have a resource data model that actually map all your resource and assets and machines and code and cloud assets into the organizational structure. And each organization looks differently. We have about 45 different fields or attributes coming from the different tools that our customers want to filter on them. And then at the same time, they also want to create some dashboard that take that combinations of assets and filters and context and actually make live updates or live decision about what information they actually want to pull and to summarize it by different perspective, whether those are categories, whether those are due dates, whether those are severities, whether those are tickets. So we got into a situation where we have a lot of data, and at the same time, each and every one of the customers is using that differently. So anything that we were looking at around, prefetching, caching, understanding, profiling queries was almost a dead end, because every time that we have profiled something and we were getting that very good in terms of performance and query time, another customer came with a different type of query or with a different type of field combination, and we were going down the rat hole again of slow queries and a long time to respond, to a point that it was not usable anymore. So when we get to the understanding that we have a problem of scale multiplied by the customization, multiplied by the fact that most of our customers want the data on demand, and it's not a batch jobs that happens, once a month or once a week, we understand that we need something else, that we cannot continue look on standard databases, on Postgres, which we were using and still using to some extent today. We cannot keep looking on optimizing query and running indexes and things like that. We actually need to do something that will help us to scale it up in the sense that it will take away most of the considerations that we have around the query times and performance. And this is where we started to adopt the ClickHouse. So in the very high level architecture, our source of truth, our source of record source of truth is Postgres. Our ETL pipeline, our extraction, transport, and translate load layer is loading at the end of the day to Postgres. We then use, we started with PeerDB, now with ClickPipes, to do a real-time replication of Postgres into ClickHouse. We got to the point that we have very, very minor to none delays in terms of getting the data from Postgres to ClickHouse. But then we did something very, very interesting. Essentially, every table that originally we had in Postgres became a materialized view in ClickHouse. And then we actually use a very specific algorithms, a very specific functionality of ClickHouse. The engineers on your side can actually go. There was a blog post about that, and there is a meetup coming about that, on how we actually take multiple materials view and make them as one view, making sure that we take from each and every one of the views the relevant columns. And we ended up with one big table that I think that right now it includes something like 62 different columns of different types in different data formats. But we are querying one big table that allow us to do all those queries that I presented in real time, group by any of the fields, filter by any of the fields. And the result was actually very, very impressive. We got to the point that our P95 was less than 3 seconds. 95% of our queries was finished below 3 seconds. And the others was not far behind. Just as a comparison, before that, our P95 was around the 40 or 50 seconds, where many of the queries just timed out after the 2 minutes timeout that was configured. But the most important thing, I think, was the removing the data-oriented obstacles from our roadmap. Before that move, every discussion we were having, we were considering whether we will be able to scale that, whether we will be able to query on that, whether what kind of testing or work we need to do in order to make sure that the performance is in line with what we expect. Most of those discussions are gone. They are still there, for sanity checks, but they are not there as a consideration. They are more there to make sure that we test that before we release. But we kind of got into the position that adding more data, adding more columns, adding more filtering options or group by options is not something that we are concerned with. It's not something that we are adding extra layer of optimization on top of, because we are actually was able to scale since the inception of ClickHouse very much with adding more and more data without the need to go back and do refactoring or engineering work about query optimization and so on and so forth. And the last one, our customers are actually very happy. They are getting the data that they need in a very timely manner, no matter if they have like 300,000 findings, which is probably our smaller customer, to 200 million findings, which are our largest customer. All of them reports consistently the same performance and the same response metrics in a way that allows us to scale and to make our customer community very happy and in line with their requirements. That's it in a very high level. Happy to take now or later any question that you guys might have.
Ravid, thank you so much. I think we'll save some questions to the end. I do think it's really compelling, the notion of the requirement for scale, the requirement for on-demand, and the desire for customization for your user to be able to customize, and sort of the implication that comes from that of a data store like ClickHouse being able to serve those needs for you, to allow you to build the use case that your customers really require. Yeah, I'm biased, but that's exciting to me. So thank you so much. I really appreciate the time. And in fact, I think I'd love to hear, sort of an analog to this, or the story of this from perhaps slightly a different perspective. And Nir, if you wouldn't mind, would you share with us sort of your take on what your journey has looked like with ClickHouse from the perspective of Reco?
Yes, of course. Hi, everybody. So my name is Nir Barak, and I will show my slides. Okay, I hope everybody can see it. So as I said before, my name is Nir Barak. I'm a principal engineer at Reco and architect. I've been here for the last 3.5 years, and in general, I've been working with data for over 10 years now. So I've seen, like, I think, pretty much everything from like the bases of ER and HDFS for old guys like me, and Snowflake and Databricks and all the new age things. And finally, ClickHouse, which is my favorite. I'm a little bit biased, but I think you'll agree. And I'd like to take you on a journey of how we managed to replace, I wouldn't say everything because it's never really possible to move everything, but 90+% of our workload we've removed completely from Postgres and moved it onto ClickHouse with almost no drawbacks. Actually, just advantages I can think of, like the cost has gone down, the speed has gone up, the scale of our customers has increased exponentially, and basically good things. So I have 15 minutes to talk about this. If you had let me talk about 4 hours, then I would also fill 4 hours, but I'll try to do this as quick and simple and painless as possible. So I have a couple of mandatory advertisement slides, so bear with me. Reco, we are a dynamic SaaS security company. If you're familiar with Wiz or Orca or cloud security companies, we are doing something similar, except we don't look over your cloud enterprise. We don't look at AWS or GCP or Azure. We go further and deeper into your SaaS application. So think of something like Microsoft 365 or Salesforce, Monday, Workday, pretty much all your large enterprise applications, and also the small ones, what we call the long tail. We monitor, observe, and remediate and respond to anything very quickly. And we, just as a couple numbers, we've got 200 integrations supported. That means we can actually connect via API to these applications and fetch audit logs and emails and events that happen in real time. And in general, we can discover over 60,000 applications. That number keeps growing every day. And we do a suite of solutions. We can show you data exposure. That means like if you have files in your drive and you have overexposed those files with permissions or identity governance, such as SSO, MFA, all those basic misconfiguration settings, threat detection and response, application discovery, and SSPM, posture management, which is alerts and threats. We do all those things in one big suite, which is mostly based around ClickHouse and its performance. Because their number one requirement is to be fast and to be able to respond in near real time, because otherwise there's no really no point to being a cybersecurity system if you're responding within a week when something happened 10 minutes ago. So a few dashboards, we've got files and application and alerts. Just think basically Datadog, if you're working with that, or Grafana or things like that. We've got dashboards for everything and monitors for everything, and everything is updated in almost real time, including counters and distinct values and aggregations and stuff like that. And most of it is driven by our AI-driven system and our identity-centric system. What that means is that we have, at the core of the system is an identity. An identity is a person. So say myself, Nir Barak, I am one person in the real world, but behind the scenes, I can be connected to 10, 20, 100 applications, and each one has a different account. Somebody needs to be able to consolidate that into a single entity. And that way we have like a context where a very broad perspective of what you're actually doing in your system. So we can be able to see an account that we've never seen before and say, okay, this guy maybe is doing something weird, like downloading a payroll file, but somebody else, a different account, which we know is connected to the CFO, for example, that's fine, that's his job. We don't need to give you a false alert in that. So that's what Reco does in a nutshell. Some numbers. So we do both very heavy reads and very heavy writes. We've got about 10 to 12 billion JSON ingests daily. We have a very special extraction method, which we patented on our side. Tens and hundreds of billions of reads and writes every day. Scans, which is the backbone of ClickHouse. We scan continuously over the entire history of all the data of all our tenants. This comes into petabytes of size every day, and Postgres is just not something that can do that, and ClickHouse does it in like seconds. So why ClickHouse? So basically, Postgres, I'm not going to go over the differences in database. I'm assuming most of you guys know like the gist of the difference between OLTP and OLAP databases. So Postgres is basically great for like needle in a haystack kind of work, like finding a specific ID in a specific table, or doing very selective aggregations and transaction work and stuff like that. It's fantastic. Not so much when you have terabytes of data, hundreds of billions of rows that you have to aggregate and find anomalies for within a very short time frame, that's where ClickHouse comes in, right? It doesn't let's say exactly match or parody the features that Postgres does, but it does it so quickly that you might not even notice the difference between a 10 millisecond response time and a 100 millisecond response time when it comes to dashboarding and other features that you need to show in real time to your users. And we began something like that I heard before, that I'm actually glad that he talked about before. The synchronization between Postgres and ClickHouse is what we used to do as well. And it worked great for a few years. But then we started feeling the pain of maintaining two separate databases. Change data capture synchronization is not always as simple as marketing makes it seem. There's a lot of transformations involved and schema changes and migrations. It's not fun to do in a general sense. Real-time enrichments sometimes works great, sometimes not so much, depending on the table and how you partition it, how you index it. And additionally, maintenance jobs that you do once in a while, like deleting things and updating things, and just let's say touching your data can incur many issues that just won't happen if you have it in a single source of truth database. Pick whatever one you want, but you pick one, and usually you can get away with a lot of overcome a lot of challenges, but just not having to synchronize it somewhere else. If somebody has ever seen long-run vacuum jobs in your Postgres, I hope you can feel the pain I'm familiar with. So, okay, let's get to some actual details. So ClickHouse is not a relational database, right? And it's not ACID compliant. But as we found out, it's not necessarily something you must have for all of the system for it to work as much as fast and as correct as you'd like. For example, role level security, this is a basic feature, role-based access control as well. ClickHouse actually has more configurations for policy creation and tenant installation than Postgres has, at least in my experience. So that was surprisingly a very simple thing to move. But updates and upserts, this is actually something interesting because the way you do that in Postgres is you run a query called onConflict do update, and you update whatever you want to update. And sometimes you don't know the exact rows or the exact things you want to insert. Whereas in ClickHouse, you just insert a row. You don't care what's already in the database. And at some point in the future, it gets deleted. And you do this by using an engine called replacing merge tree, which is a specialist kind of merge tree table in ClickHouse, which behind the scenes, when it does the merge, it replaces the rows with only the last one. And you can see the change immediately if you run a final. Same with deletes. There's an engine called collapsing merge tree, which I wouldn't necessarily recommend using all the time because it requires you to be familiar with the state of the table. So usually be careful when you do this because you need to know, if you're familiar with this kind of engine, you need to know the signal. If a row has already appeared before you delete it, there's actually a really good new feature coming out. It's already come out, I think, in the open source version, and in the cloud version is coming out within like a month, of lightweight updates and deletes. I think they call it FlightWeight now. I haven't had a chance to use it, but I'm really, really hopeful it will come out soon. One thing I want to mention regarding upserts in ClickHouse, we found a curious case where our data, which comes in real time, comes in batches, and they're not necessarily always coming in order, right? Sometimes we have late arriving data coming in with real-time data. And a curious case happened that we saw that even though the newest row was inserted last, the previous row actually was the one that won the replacement. And the reason for that is for a caching mechanism inside ClickHouse that does batches and stores things in memory so that it can more efficiently flush the disk. But that small batch interval, that the flush time, could actually cause your flow to select the wrong row to be inserted. So if you are like us and you have a real-time engine and you need fast updates, delete that, disable that duplication setting. And if you're using final like we do, turn on the skip index. If final exact mode, that's a relatively new setting. It used to be only final, which lets you see the last part. Moving on, transactions. So that's pretty much the only, the biggest, I'd say, pitfall of ClickHouse. It doesn't really do transactions. And that's fine. We don't really need transactions for most of our cases. Unless you're in a banking system or you have some regulatory requirements, it's okay to implement an idempotent system rather than an ACID compliant system. And just, you can call this eventually consistent, but it's basically, it's okay if things aren't committed, as long as you don't have too many tables and you don't do too many weird joins. Just insert the thing and it'll get there eventually. It's fine. And in our case, where we have tens and hundreds of billions of rows inserted, I have yet to see a deal breaker without using transactions. Materialized views. So Postgres only has a basic one, which is a full refresh of the table, whereas ClickHouse has two types: the classic incremental one, which is based on the aggregating merge tree, which updates incrementally every time we insert a number of rows, say 100,000 rows. It does some aggregation on that specific type, and then it merges it into the materialized view as a whole. And then there's the refreshable materialized view, which I think was released last year, somewhere towards the end. And we actually found a combination of the two. So we are tenant-based, obviously, we are B2B, and we are refreshing our system by tenant. So each tenant can have different refresh intervals and different data sets that we need to update. And not necessarily we want to update all the tenants at once. So we implemented a sort of, pretty much a very similar implementation of the refreshable materialized view, except we do it at the partition level. And thankfully, ClickHouse has a lot of great features for partition-specific queries, such as the replace partition. So if you're able to write the query, the refresh SQL into a temp table at the side, and then swap it using the replace partition, you're pretty much getting an atomic refresh, same as you would with the regular, the classic refresh materialized view, without having to refresh the entire table. There's also joins, which I know get a bad rap in ClickHouse. I'm not sure why, how this started, maybe like 5 years ago, but since then, joins are pretty great, actually. I wouldn't recommend joining billions upon billions with billions of billions. Obviously, partition pruning and predicate pushdowns are the way to go here, but joins as a whole, especially if you have the dictionaries, which are stored in memory, are really fast. And additionally, they have lots of different, very specialized, I call them boutique types, like the ASOF and the paste and the any type of joins. You can use freeware to do predicate pushdown, stuff like that. They don't have all the types, right? There's something called lateral in Postgres, if you're familiar, which is one of my favorite type of joins. It doesn't exist, but you can simulate it in ClickHouse as well. So basically what I'm saying is, you can do a lot of things with ClickHouse without having to save your data beforehand in Postgres. Unless there's some specific requirement, it's really good. I have a couple more slides to talk about, some other tricks we do here at Reco. So we use ClickHouse Cloud. And a recent feature they've released a few months ago was the compute separation. We were the first to get into that. And basically what we do is we offload all of our non-real-time work, heavy analytical work, into that compute separation. So we do all our materialized view refreshes and very large updates, stuff like that. We did it on a separate warehouse. And then that data is automatically synced to the, let's say, the customer-facing one. And that somehow managed to reduce the cost, because the way a lot of things work in ClickHouse is before you say you do a very big join or a very big refresh, in the general case, the data is first moved into memory before it's flushed to disk. And what happened is that the data somehow would cause an out-of-memory error, because you had billions of rows you have to write, and we had to resort to using like 3 or 4 64 plus gigabyte nodes, which were really unnecessary, because most of the cases you don't need that much memory to scan. So moving that to a different warehouse solved that issue and reduced cost. Additionally, you can limit the amount of memory used by using some very nice settings, the max bytes before external group and the max one before sort. There's also a new one released, I think, last version, the 25.6, that is called parallel distributed insert select equals 2. 2 is important here. It basically, it shards your aggregations and your joins into different nodes so that each node does a subset of that aggregation and then sorts it, saves it into their own node separately. Which is fantastic. It like dropped our resource requirements by like a third. And finally, the obvious one is use indexes. Indexes are really cool. They work really great for something that doesn't actually index every row. They'll use a sparse index. It's surprisingly very, very accurate. And I hope I have a couple more minutes because I have a little bonus slide. We use Spark, which I assume most of you use something similar, if not Spark itself. And we store our state in Spark. So you have real-time data coming in, and you usually want to be able to see what state, whatever event came in. If you've had some before, you want to be able to do some basic aggregation before you push it forward. And we used to use the in-house Spark state store, if you are aware, if familiar with this concept. And very quickly we ran out of memory, and the whole thing with S3, we use AWS and synchronization and checksum issues. The whole thing just became a mess, and we were cleaning up like corrupt data all the time. And then we tried to move to Redis. Redis also very quickly became like untenable in terms of cost. And then I found out that ClickHouse, not the cloud one, the open source type, supports RocksDB as an embedded engine, which basically means behind the scenes, you have a fantastic key value store. RocksDB is fantastic. With an exposed SQL layer, you can communicate with without having to run in process, which is the usual case with RocksDB. So we spun up Kubernetes pod using ClickHouse with the RocksDB. And since then, I think we've been running with this for like 2 years now, with billions of events and states and events and just everything. I haven't even thought about this until I wrote this slide like this week. So it works. And I think that's it. So thank you very much. And I hope I didn't bore you too much.
Not at all. Not at all. And for those of you who aren't familiar, the concept of a table engine in ClickHouse is, at its simplest, it's the type of table. And it determines how and where data is stored, what queries are supported, data access, type of indices, use of indices. But there's also a class, and you can think of the traditional engines as being like merge tree, replacing merge tree, summing merge tree. There's a class of table engines called the integration engines. And those include things like Azure Blob Storage and Iceberg and Hudi and Hive and embedded RocksDB. And also Mongo, MySQL, Postgres. So the table engines are actually a really powerful way of beginning to interact with data wherever it resides using ClickHouse as the sort of equivalent, if you will, of a query engine. Nir, thank you so much. Ravid, if you wouldn't mind joining us back on video, there's a couple of questions that have come in that I'd love to just ask for both of you, and we'll just kind of have a conversation about it. Some that were submitted beforehand, some that have come in chat. So I'm going to kind of loosely group some of these together. You both sort of talked through the story a bit of Postgres to ClickHouse. There's a couple of questions that have come in as it relates to, some of them are very specific, and diving into specifics of data modeling, the best answer to that is usually go play. But I'd love to get your thoughts on, hey, someone has an existing Postgres system, they're interested in ClickHouse. What should they be thinking about doing as they're thinking about sort of the data modeling work that they need to do when migrating from Postgres to ClickHouse?
I'll take this, yes.
Sure.
So the first thing you should know is data looks different in ClickHouse and Postgres, obviously. So what you used to do with a single, like let's say you have one fact table and dozens of dimension tables, and you do tens of joins, that query, that no longer suits the case for ClickHouse. The best thing you could do is denormalize the table into a single very fat table, which is what Ravid talked about. And secondly, try to not hurry into moving unless you really need to. So it's very hard to migrate things, especially data. And it often comes, I know it's not supposed, I'm not, with this talk is about ClickHouse, but If you have a working system and you're not ingesting billions of rows, let it work. Make it work in your system before you move it. But if you do need to, then first of all, duplicate the data. Don't start moving everything and then stop writing to the other one. Live with both systems at the same time and learn the patterns and the drawbacks of every database before you make the change. I recommend highly ClickHouse. If you have to choose something, choose ClickHouse. But you need to know your stuff.
Yeah, I would say Postgres is one of my favorite databases, right? It's fantastic for what it does. It's the place to start, but when you need ClickHouse, you need ClickHouse. And I don't think it's really it's sort of an either or, it's a sort of a yes and I think, Ravid, that's a bit of what you were talking about with sort of the story of ClickPipes and Postgres CDC. And
So-
would you just touch on the modeling aspect a little bit for me?
So I think Neil also mentioned that. Neil said that at some point in time they were doing the replication and then they moved to load all the data directly to ClickHouse. I would imagine if we will talk a year or 2 years out, we will probably be in the same situation because the overhead of managing two databases and also the cost, by the way, doesn't worth it. But definitely I agree with Nir. Let's start with replicating the data, move the queries, move the parts of the system that actually requires the heavy load, and then slowly but steady move the rest of the ingestion and everything. Which is why we are in the process of still replicating everything from Postgres to ClickHouse. Generally speaking, we replicate everything almost as is, and then we are using materials view and then merge tree later to actually move from one data modeling to the right data modeling for the query that we need. So at the end of the day, the queries that we have running against ClickHouse are not queries that there is an equivalent table in Postgres. Okay, so we are moving the data and then using different capabilities, we are remodeling that to meet the purpose of the queries that we need to do. And I think that just replicating and running the same queries, it will not run faster for you. Okay, maybe it will, but it won't be order of magnitude. The idea is to take that data, which was modeled for dimensions and views in Postgres, and make it to be to meet column RDB for the right queries. So definitely replicating is just the first phase, but then you actually need to model the data correctly. I think you're on mute.
Yeah, I just wanted to say one thing. I was surprised actually. One of the things I was surprised between the differences between two is actually arrays. So in Postgres, arrays are a bad thing to do. Like if you have more than, 10 items in an array, you're doing something wrong, especially if you're joining on that. And in ClickHouse, somehow, I don't know how they do it, but like you can put 100,000 items in an array and then just do contains like has on that array and just works like that. It was surprising. So exactly what Ravid said, you need to know how to model your data for your database. Just copy paste doesn't work.
Yeah, that makes total sense. And then sort of building on that, what's been the biggest surprise for you in your journey with ClickHouse? Has there been a moment where you're like, this is really cool, or oh, I wish it did this other thing?
So for me, actually, the thing I liked that was surprised was the more of a maintenance thing. So Postgres has this issue where you cannot really limit a query's specs. So you can't really say use only X amount of memory and Y amount of cores and kill it if it takes too long. You have to manage this by yourself, or you need to buy a third-party vendor that does it for you. ClickHouse has profiles, and you can, I think I saw in the latest release, there's even more features added. So it was very easy to, for me as a data engineer that was building the infrastructure, to just blame the other devs when they were doing a bad query, say, hey, your query sucks, and ClickHouse killed it, go fix it. Whereas in Postgres, I had to, find the guy and figure out why it wasn't working, and then risk the entire system going down before I could find the issue. So that was nice.
Yeah, I think in a very similar way. I remember the amount of discussions about bloat and vacuum in Postgres, and routine maintenance and what is the right time and how to do that and re-indexing and a lot of that housekeeping to prevent the system to become slower and slower as you move forward. And all of this was mostly gone away as we moved to ClickHouse. The transition to ClickHouse took some time, making sure CDC
Mm,
right on time and there are no synchronization failures and all the data modeling and everything. The transition was taking a long time, but once it's done and finished and we got to the production state, the maintenance overhead is very low.
mm. Gotcha. That's very interesting. I'm always intrigued by that. And like I said at the beginning, I'm lucky enough to travel around and talk about ClickHouse a lot. And it's a question I always ask because everyone's experience with it is different based on where they're coming from, what their experience was before that. To shift sort of focus for just a second, I think that this is a rare opportunity for those of us who are on the call or who are going to watch this video in the future. You both are in sort of very senior positions at successful startups. I'd love it if you wouldn't mind. What advice do you have for those who are watching this, who are in the building phase of their company today, or in the building, trying to figure out what their next thing is? What advice would you give to others who are exploring the data space now?
Wow. I always say that we always need to remember that technology, as a general, is a supporting role in getting our customer use cases. And without understanding them, okay, you will not find the right technology solution. And that should be your North Star. So, ask me if I would open a new company tomorrow and I will go directly to ClickHouse, not before I understand my use cases, not before I understand what is the information that I need to provide and what is and what are the things that we need to do. And generally speaking, I think technology, we are talking about technologies and the bits and bytes of everything, but I think the success is because it's aligned with the requirement, because it's aligned with the use case, not because just the technology works. And for everyone that start this journey right now, make sure that you understand your requirements. Even if you start with the wrong technology, if you will move to other technology based on a clear requirements, that will be successful. Otherwise, it's just moving bits from one side to the other.
I mean, I completely agree. There's a saying I really like of sometimes people are making solutions while looking for a problem, and not the other way around. And it's very common to get like a deer in the headlights kind of situation where you're super excited about this tech stack or about this technology you want to use, the cloud, for example. AI is a big one. And you don't really have a reason to use it, but you really want to use it because it's so cool. So I would suggest, like, if you're just in your journey, starting in your journey, get your bases covered. So most of the issues I've worked with in the data are not actually directly connected to that data, but it's actually more of a management issue. So role-based access control is a really big one. Like in this company, for example, we started by going really fast and breaking things really quickly, so we can have much. And then we discovered that actually, what most large enterprises care about is segmenting their user base to use the data correctly. So then we had to rethink our entire ecosystem around that policy control. And it's something that's very often, as engineers, you don't care about because it's not interesting enough. It's not the latest and most sexy, cloud DB vendor, but this is the number one thing that makes or breaks companies, like the basic infrastructure.
No, it's incredibly helpful. Thank you both so much for that. We're coming up against time. I need to make sure that that also we free up the Zoom for the next meeting. I did want to say, for those of you who are still watching, if you are interested in exploring remediation without bottlenecks, and you were found what Ravid was talking about incredibly compelling, check out Seemplicity.io. It is worth spending your time looking at it. And if in listening to Nir's talk about sort of the scale and scope of what they're doing, and dynamic SaaS security is something that's of compelling need to you or something you're interested in learning more about, please check out Reco.ai. Both of these are incredibly compelling offerings. And as a member of ClickHouse, it's always humbling for us to see the technology that we've built enabling others to build incredibly exciting companies. I will also tell you, if you're watching this, that you're going to get an email from us in about 24 hours that has a link to the video. If you have other questions, please feel free to follow up with myself, with others. You can check out clickhouse.com. If you go to clickhouse.com/Slack, you will see our Slack community. And if you go to the ClickHouse and click on the events section, or go to the GitHub README, there's something like 20 meetups coming up between now and the middle of November, all around the world. In fact, in places that I saw come up here in the list, like Tel Aviv and Madrid and Barcelona and Zurich and London. In fact, there's one happening right now in Sao Paulo. So please come join us at an event as well. Join us on Slack. Nir, Ravid, thank you so much for your time. We really appreciate it. And to all of you who watched, cheers. Have an amazing day.
Thanks, everyone. Thank you.
Bye.
Thanks, everybody.